This problem also has an axis of rotation that isn't one of the coordinate axes. Also has some trig functions. So maybe this will be a little bit more of a challenging integral. Not too bad because we haven't really learned a lot of challenging integrals yet, but you know, a little bit different than the other. So again, it's the same deal. First, we're gonna draw a picture. Now, I happen to know, because of what I know about trig functions, that these guys, sine and cosine, they're gonna match at pi over 4. And so here's one. And you know what? Let me make that a little bit smaller because we have to rotate it around. Okay. So here's one. Sine is gonna go up this way from 0 to wherever, and cosine is going to go down this way from 0 to wherever, wherever being pi over 4. Maybe if I had drawn it a little bit better, I could just keep it right there. We know that they're going to intersect at pi over 4, and they gave us the pi over 4 anyway and the 0. So this is the region that they're interested in. So let me maybe double check or make sure that I have my curves labeled so I know which one is which. The one that starts at 1, 0, of course, is cosine of x, and then the other one is going to be sine of x. Okay, so that's my region. I want to rotate it about the line y equals -1. That's why I made my graph a little bit smaller, just so that I could fit it on the page. Um, but here's my axis of rotation, and we're going around like this. Okay. So again, you can kind of try to picture this in your head. You can see that it's going to be kind of, I need to make this a little bit bigger, I guess. Oh, failure. Oh, wait. So it's going to be something like this, right? Not, that's a terrible picture. Let me try one more time. Again, your sketch, it just helps you figure out the problem. That's all it's for. So if you can understand it, I can kind of see what's going on. That's the important thing. So imagining this as a cross section of whatever angular thing this looks like, if I cut down what the cross sections are, again, we're going to have the outer radius being here, and the inner radius is going to be like that. And this has a thickness because it's a washer. So the thickness again is going to be in the x plane, in the x coordinate. So we are going to be taking the integral with respect to dx. Okay, so that means that the volume pi from wherever to whatever, r out squared minus r in squared, and it's going to be dx. Well, first thing, whatever to whatever is easy. It's great. They told us what it was. They told us they wanted it from 0 to pi over 4. So all I have to do is, I don't have to solve for anything. Just throw that in. That's great. I feel like this is just making it harder to see. So let me get rid of that. Um, I'll put that we have a width dx here, but when I drew the width, it just looked ugly. So without the width in the picture, maybe it's a little bit easier to see the different radii. Again, for my radius, if I want to go from the red line to the top curve, here's my red line. I'm going all the way to the top curve. What do I have? I have this distance, which is y, and this distance, which is 1. So my radius is going to be y plus 1. And again, it's going to be the same y plus 1. It's going to be y plus 1 also for the inner one. It's just the y is going to be different because in the outer radius, I'm going to the top curve, which is the cosine, and in my inner radius, I'm going to the bottom curve, which is my sine. But in both cases, I want to put a plus one because I'm I'm moving over. I'm having a large hole in my rotation guy. Right. So now I've got it all set up. That's the hard part for most of these. I'm gonna put it in and I'm gonna do the integral. This one is slightly different than the previous examples because I do have those sines and cosines in. And yes, you'll see that there's a square. So let's work that out because when I look at that, I can't say actually how to integrate that just from looking at that. So, oh no, I'm sorry. All right, let me work this out. Work out those squares. I'm going to get cosine squared x plus 2 cosine x plus 1 minus this guy and then plus 2 sine x plus 1. Well, at least the plus 1's cancel out. So here's the thing. Looking at this, this is not obvious how to integrate this, right? Um, Cosine x and sine x, we can handle that. The ones cancel out, that's fine. But I've got cosine squared x and I've got sine squared x, and we do not know how to integrate those yet. We will learn how to integrate those in chapter 7, but we're not at chapter 7 yet. So we don't know how to integrate cosine squared x because it's not just sine squared x. So I kind of have a problem here, but I do know the solution, so I'm going to tell you what it is. Luckily, we don't have cosine squared x and sine squared x by themselves. We have them together, right? And you might think, oh, yay, they're going to just be 1, but you'd be wrong because it doesn't have a plus. It's a minus, right? If it was a plus, that would just be 1 because cosine squared plus sine squared is 1. That's the Pythagorean identity. But it doesn't. It has a minus. So after going back and checking that the minus is correct and then being annoyed by that, now you need another identity. This is actually cosine of 2x. So a double angle identity. It is on our sheet of things everybody should know. Cosine 2x and sine 2x are on there just because they pop up every now and again in this form. So it's just a good thing to have in your back pocket. Okay. Don't see it that often though. It's not that often used, not like the Pythagorean identity. But anyway, I can use this identity. I put that in there, and that guy just becomes cosine 2x. And then I have all these other guys here that I need to integrate, and I can integrate all these things really easily now. Right? The first one is just an easy use substitution. Derivative of sine is cosine. So I'm going to have sine of 2x, and then I have a 1/2 to take care of the 2, and then derivative of sine is cosine. So I got this. And in fact, look at that. Um, derivative of, okay, derivative of cosine is negative sine. So I'm actually pretty happy here. All of my negatives turn to positives, and all I have to do is evaluate. So let's see here. I'm gonna put these in. Sine of pi over 2 plus 2 sine pi over 4 plus 2 cosine pi over 4 minus plus 2. So now why am I doing 0? Because cosine of 0 is 1. So I cannot forget it. Okay. So this guy is fine. Sine of 0 is 0. This guy is fine, but cosine of 0 is not 0. Cosine of 0 is 1. Okay, and so let's see what we have here. Sine of pi over 2 is 1. Sine of pi over 4 is root 2 over 2. Cosine of pi over 4 is root 2 over 2. And then subtract this 2. That would be cosine of 0. Okay, so I have 3 halves. So I have negative 3 halves, and then I have 2 root 2, and then I am done.